Question 1. We've got work out 90,000 plus 8,000 plus 8 plus 0.5 plus 0.02. Now you could draw those all in a column and just be really careful about it. Or you can see that I've got that's the 10,000s column. I'm going to have a 9. In the 1,000s column, I've got an 8. Now this is the bit where people may go wrong. There's nothing in the hundreds column and there's nothing in the tens column. So we're going to have 2 zeros. A 0 in the hundreds column, a 0 in the tens column. Then I've got an 8 and I've got, that's the tenths column, so I'm going to have a 5 there. And that's the hundredths column, so I'm going to have a 2 here. And for this one, similar, I've got the 10,000s column, the thousands column, nothing in the hundreds, nothing in the tens. For nothing in the tenths, a 6 in the hundredths, and a 9 in the thousandths column. Question 3. 55 times by 15. I want to see some sort of working out. You know, it could be a column method. If you've learned a grid method, in general we work with a column method, or any kind of other method like a mental method, which could be something like this. I might do 55 times by 10, just in my head, and that would give me 550. And so I know that 55 times by 5 would be half of that amount. And so half of 500 is 250 and half of 50 is 25. So that would be 275. And then I could add those together. So whatever method you have, if you have a column method or some other method, I want you guys to be good at working with lots of different methods. So we should have 825. Question 4, 77 times 34. This one's perhaps more lends itself to a formal column method. So 7 times 4 is 28. 7 times 4 is 28, 29, 30. Put a 0. 7 times 3 is 21. 7 times 3 is 21, 22, 23, 2, 3. So I've got 2,618. Again, I want to see some working out, so we're making sure that we're not just using a calculator for it. Okay, otherwise I can't tell that. Question 5. You guys probably haven't seen this at primary school, so it may be something completely new. Okay, but it's actually really straightforward. What this is called, if you want to look it up and work on it, it's called collecting like terms. And what I mean by a like term is I've got A's here and I've got B's. I've not got any C's or X's or anything like that, but I'm going to collect the like terms of A. So I've got 9 A's, take away 8 A's, gives me 1 A. Okay, so these two, 9A take away 8A, gives me 1A, which I can just write as A. If I've got 1A on its own, I can just write that as A. I've got plus 2 B's, and then take away 3 B's. So 2B, 2 take away 3 would give me minus 1. So it's like I've got minus 1B. But if you have one of the letter, you can just write it as that. So that's like 1A take away 1B. But I can write that as A take away B. Question 6. 9A plus another 7A gives me 16A. So I'm going to put those together. And 5B plus another 8B gives me 13B. It's just as simple as that addition like that. You just have to go, just have to see which one's which. Question 7. Work out the value of 2B plus 6 when B equals 9. So this is called substitution. And what we do is we say, right, when B equals 9, so it's like 2B. So that's like 2 times by 9. If they're next to each other, we multiply them. So it's not 29. If it's next to each other, if you've got things which are next to each other in algebra, we multiply. Okay, so we're going to time. So it's 2 times 9 plus 6, which gives you 18, plus 6, which gives you 24. I would really understand it if right now you did 29 plus 6, but it doesn't work that way. If things are next to each other in algebra, we have to multiply them, not just turn them into a number. Okay, c minus 5 when c equals 15. So I take this 15, put it in there. I've got 15, take away 5, which is just 10. Okay, question 9. Again, you may never have seen this before. I suspect you never have, knowing what a significant figure is. Significant means important. And if I'm rounding something to one significant figure, it means I'm rounding it to the most important figure there. Okay, so what I need to think about with this number is, if I changed any of these digits, which would have the biggest effect on the size of the number? What's the most significant figure? And it's this one, isn't it? Because if I change that, it could either become 113 or 313. That is the most important number. It changes the number by the most. Okay, so if I'm rounding to a significant figure, I want to look at what column is the most important column and round to that column. So I need to see, this column is the hundreds column, so I'm going to round to the nearest 100. So what is this number to the nearest 100? It's 200. And with this one, what's the most important column with this number? It's the thousands column, so I need to round to the nearest 1,000, and this is just 2,000. It's closer to 2,000 than it is to 3,000. Okay, question 11. I saw when I was coming round that quite a few people maybe weren't too sure about this sort of question. I've got a number divided by 9 equals 11. So what I need to do is see what number would that be if when I divided it by 9 I got 11. I can reverse the process by multiplying by 9 and you would have the answer x is equal to 99. Next question, something take away 4 is 3. That something must be 7, right? We all know 7 take away 4 is 3, so that number is 7. Next question, 13. Find the missing terms in this sequence. So we're going up 9. I wonder if we keep going up 9, if it's going to work. So let's see. If I went up 9 from 33, I would get to 42. And if I went up 9 again, I'd get to 51, and then I'd get to 60, so that's definitely right. So the two numbers missing are 42 and 51. Now this one's a little trickier. We go from 27 to 23 to 19, so that's going down 4 there. Now, if it's going down 4 between those two, then it must be going down half as much for each of these. So it would be 25, 27, 25, 23, 21, 19, and so on. Question 15, expanding brackets. Again, I think you've probably never seen this at primary school. In fact, I'm pretty sure you wouldn't have. So we're going to do the number outside multiplied by each thing inside. So I've got 3 times by 1 gives me 3. And then I've got 3 times by, now I'm going to times it by all of that bit. Okay, so 3 times, I'm going to include the sign before. So 3 times by plus 11x. So that's going to give me 33 lots of x. If you think that is 11 lots of x, and I times it by 3, I've got 33 lots of x. Same idea here. Make sure we're multiplying the second one by that. So I've got 15. Now my negative numbers comes in. I've got a positive 5 times by a negative 11. Positive times a negative gives you a negative minus 55x. Okay, question 17. This one you guys should know from primary school. 140 millimeters. There's 10 millimeters in each centimeter, so that would be 14 centimeters. Yeah. Photographs. What about them? Yes. Meters to centimeters. There's 100 centimeters in each meter, so 39.2 times by 100 would be 3,920 centimeters. What is the third cube number? Right, so a cube number is a number times by itself 3 times. So that 1 cubed is the first cube number, 1 times 1 times 1, which is 1. 2 cubed is the second cube number, 2 times 2 times 2, which is 2 times 2 is 4, times by 2 is 8. The third cube number is 3 times by 3, which is 9, times by 3, which is 27. The 9th square number. So square numbers go 1 squared is 1 times 1, 2 squared, 3 squared, 5 squared, for example, is 5 times 5, which is 25. So the 9th square number is 9 squared, which is 9 times 9, which is 81. Okay. Right.